All right, algebra guys. Sorry about that. Here we go. Scatter plots. So scatter plots and lines of regression. Actually, what we're going to do is we're going to create some scatter plots, and we're going to go ahead and figure out where that line of best fit is, and we're going to be able to predict what's going to happen in the future, possibly, because it never works, right? We talk about the stock market like this. You look at a little scatter plot. The stock market goes up, and then you predict what it's going to be like 20 years from now, 10 years from now, and it never really is. But I'm talking about something that you don't have to do right now. Let's just go ahead and talk about this simple idea. A scatter plot is just a set of data points on a graph, and if you look at it, these are scatter plots right here, and if you look here, there's no correlation here. There's some sort of negative correlation there and some sort of positive correlation there, what have you. Not a big deal. It's easy to do. What we do is we put all the points on a graph, and then we put in a line that sort of matches most of the information that we have there, and then we go ahead and we say, okay, well, if this is our line, let's go ahead and find the slope of that by using the slope formula here, y2 minus y1 over x2 minus x1, and then we go ahead and find out where it might cross whatever axis, or we put in a point and use point slope form to find out what that equation might be. And that's exactly what we're going to do with this problem here. Here's our example. And I'll show you how they got to this idea, and then we'll go ahead and do one, and we'll be finished. It says, according to a certain prediction equation, the cost of 200 square feet of storage space is $60. The cost of 325 square feet of storage is $160. Find the slope of the prediction equation. So really what we're going to do is just take these as coordinate pairs. And we're going to say that the cost is our y. We want, for this particular equation, we want money per foot. So we're going to want our distance on the x-axis, right? So cost on our y-axis, and distance on our x-axis. So here we go. We're going to say that $60 is y2. That's y1, silly. And this is y2. And then I'm going to use distance, right? So I say x1 and x2. Sorry about the little mistake there. And then they put it together here. 160 minus 60 is 100. 325 minus 200 is 125. And they have a slope of 0.8. All right, so it means 80 cents per foot, per square foot, is what it costs to rent something. Well, if we say it's 80 cents per square foot, and we go ahead and use our calculator and we say, but wait a minute, sir, you just told me it was 80 cents a square foot, and I wanted 200 square feet times 0.8. Well, that's $160. That's not what this person is being charged, is he? No. So our equation must be a little bit goofy. And so we have our slope, because it goes up 80 cents per foot, but there's something that may have been added or taken away to get there. So we found our 80 cents, or our 0.8, and then what we do is, let's go ahead and take that first coordinate pair, x1 and y1, and plug that into the point slope form, which is down here. Whoops, I went a little bit too far, didn't I? There we go. Plug it into the point slope form here, right? x1, y1. And then we do the math, and we we distribute. That's what it says there. We add 60 to both sides, and we come up with this equation. So we can estimate that if indeed you wanted a certain amount of square footage, you could put it into here and predict about how much it was going to cost. So I'm going to use that same idea and use this, this wonderful equation, prediction equation we found, and see if it kind of works. See if it works for 325. Right? 325 and 160. Let's see how close we are when we go ahead and put in 325 and 160. So I'll put in 325 here and see if I get out 160. Now, it may not be exactly that, right? But 325 times 0.8 is 260. Hey, look at that. So if I do 0.8 times 325, I get 260 minus 100 gives me 160. So yeah, I'm going to have to pay $160 for that 325 square feet. So it does work out to our for our second coordinate pair. Here's a simple idea. This is going to allow you to draw a scatter plot and then create or predict what's going to happen. So I'm going to go ahead and plot these points real fast. Years of experience, 9 up to 17, 410, 310, 17, 1019, 612, 1220. Hey, look at that. Somebody's making some money. And 815. 8 and 15. And so there's a line of best fit we can stick in here, and I'm just gonna, sort of fake one there and sort of put this would be basically our line of best fit. So if we look at this line of best fit and they want to know how much somebody's going to be paid for 15 years of experience, I could follow up this line, and 15 years is right about here, about there on the line. So we'd say they'd be making $25, $26 an hour if we use that line of best fit. Now, if we use a couple of coordinate pairs that are really, really close to this line, I'm going to say, what is that, 410, and then, and I'll use one that's, again, pretty darn close. I'll say, 9 and 17. So I'll say 17 minus 9, 17 minus 10 is 7, and then 9 minus 4 is 5, so 7, so you go up 7 over 5, and if I go 7, yeah, that's pretty cool, and I put in a 15, means $21, and then we started here at 4, so plus 4 gives me approximately $25. Okay, so I can use my y-intercept. Looks like my my line is cutting through 4. That's me cheating and getting ahead. Use all the information at your disposal. When you put in a line of best fit, if it crosses your y-axis, there's your y-intercept right there. We could, in essence, go and use the point slope form go through all the motions. It works out exactly the same. So I came up with $25 just by estimating and looking at my line of best fit. But if I go ahead and say, here's my slope, and I use, because I want to use 10 years and $19, this is going to help me find a number, only because this is 14 plus B equals 19, and okay, B is 5. So B is 5, it's really up here, my line of best fit. It wasn't perfect. Will I get $25 or $26? I was pretty close in my estimation. But if we went ahead and wrote this in, we'd say Y equals 7/5 X plus 5. I like plus 4 because I can see it there, but that's okay. And we say somebody who works there for 15 years is probably going to make between $25 and $26. That's about it. There's a whole other piece of how to put scatter plots into your calculator, but we're not going to do that. We're going to move directly on.